picking up where we left off at, we have this angle here, which is 100 degrees here. And so we have 100, 40, and 40, which is 180. And you notice that this angle is greater than 90 degrees, so that would make this an obtuse triangle. But it's also isosceles because since we have the same angles here, that means that the sides are the same as well. So we will have two sides that are the same. Now we come to D. This is an equilateral triangle. All of the angles are the same and all of the sides are the same. Now actually the name of the triangle for the angles being the same is called equiangular. So it's equiangular triangle and also equilateral. Now we go on to the next page. It says similar triangles. Similar triangles have the same shape but not necessarily the same size. In similar triangles, the angles are equal but the sides may not be the same length. Corresponding angles are angles that have the same measure in the two triangles. Corresponding sides are the sides opposite the corresponding angles. Now, triangles ABC and DEF are similar. We have the corresponding angles. Let me make this a little smaller so we could fit everything in. Okay. Now we have here triangles ABC and DEF are similar. This is ABC and DEF. Angles A and D correspond with the sides AC and DF. Angles C and F corresponds with sides AB and DE. And angles B and E corresponds with sides CB and FE. Now, go down to the next. We have similar triangles. Now we have these two triangles here, which we have similar triangles have the same shape but not necessarily the same size. We have triangle CAT is similar to triangle DOG. So triangle CAT, and this is a similar symbol to triangle DOG. Now the measures of corresponding angles in similar triangles will be equal. Measure of angle C is equal to the measure of angle D. The measure of angle A is equal to the measure of angle O. And the measure of angle T is equal to the measure of angle G. The lengths of the corresponding sides in similar triangles will be proportional. Now if you look here, we have CT, this is C and T, CT over DG. Let me see if I can make this even smaller. Okay, here we go. Scroll this up just, okay, now we have CT over DG, AT over OG, and AC over OD, and they're proportional. Now, go on to the next page. Now we have similar triangles. The measure of corresponding angles in similar triangles will be equal. The lengths of corresponding sides in similar triangle will be proportional. Now, this is a little off here, so let me move that. So now we can look at these triangles. We have the measure of angle O is equal to 75 degrees. Now, what happens here is, as you all see, this is a little off, but the measure of angle A and angle O will have the same exact degree measure for the angle. So the measure of angle O is 75 degrees and the measure of angle A is 75 degrees. Now if you look here, we would do what is called the corresponding sides. We have 10 over 6, we have AC and OD, so that would be 10 over 6, and then we have 18, which is CT, and then we need side DG, which is here. So now we want to solve for DG. Now, what I want to do is this here. I want to show you how I will go about solving it. This is what we need to do. We need to do cross multiplication. So we'll do 10 times DG is equal to 6 times 18. Now, 6 times 18 will give us, what's that, 108. And we will have 10 DG. Now we have to get DG by itself. So we divide each side by 10. and we will have DG is equal to 10.8. And that will be the final answer for that side. Now, similar triangles. The measure of corresponding angles in similar triangles will be equal. The lengths of corresponding sides in similar triangles will be proportional. So we have triangle ABE is similar to triangle DCE, which we see here. Now, we have 10 over 15 is equal to 20 over AE. Now, we know 10 is DC and 15 is AB. These sides are proportional. Now, we have 20 over AE. Now, 20 is supposed to represent DE. Now, it'll be 20 over AE, which are the similar sides. So we could do cross multiplication. We will add 10 times AE is equal to 20 times 15. So we add 10 AE is equal to 300. Divide each side by 10. And AE is equal to 30. And that will be your final answer. Now, we go down here to the next page. We have similar triangles. It says here, the measure of corresponding angles in similar triangles will be equal. The lengths of corresponding sides in similar triangles will be proportional. If the person is 4 feet and 6 inches tall, how high is the light? So we know 6 inches is half of a foot. So this is where we get 4.5. And then we have this side here, which is 10. Now, what happens is this here. This whole side here is 25. From this end to this end. But from here to here is just 10. So they're asking us, how tall is this light pole? How high is the light? Okay, so this is what we would do. We notice that we have these similar sides here. So we could take 4.5 and we can make this side x is equal to. Now we would take these bottom sides here. So we would take 10 all over 25. So now we cross multiply 4.5 times 25. It's supposed to be 25. Is equal to 10 times x. 4.5 times 25 would give 112.5. That would give us is equal to 10x. Now we divide each side by 10, and then this would give us 11.25 is equal to x. And that is our final answer. Now, it says here similar triangles. The measure of corresponding angles in similar triangles will be equal. The lengths of the corresponding sides in similar triangles will be proportional. Find the length of CD. Now, if you notice here, this triangle is flipped upside down, basically. So if we flip it right side up, let me just do this here. I know this is not coming out straight, but you get the visual representation. If we flip this right side up, this would be side E. So now we have the triangles on the same side here. So now what we want to do, we want to find CD, which is this side here. Okay, so if we look at the proportionality, we notice that BC, which is 12, is proportional to side CD. So next, we set this equal to. Now, we have CB over CD. So now we could take AB, which is 9, over DE, which would be 15. I didn't write that here, but this side here is 15. So now let's go back over that again. BC is 12, and CD we don't know. And then now we will go here. AB is 9, and DE will be 15. So now we will cross multiply. 12 times 15 is equal to 9 times CD. 12 times 15 is 180. It's equal to 9 CD. We divide each side by 9, and 20 is equal to CD. And that is our final answer. Now, we come down here. It says example. A person who is 5 feet tall is standing 144 feet from the base of a tree, and the tree casts a 156-foot shadow. The person's shadow is 12 feet in length. What is the length of the tree? Okay, a person who is 5 feet tall. Let's do this. We're going to add two triangles. Of course, my triangles aren't perfect, but you get the idea. A person who is 5 feet tall is standing 144 feet from the base of a tree, and the tree casts a 156 foot shadow. The person's shadow is 12 feet. So we could do this. The person's height is 5 feet. The person's shadow is 12 feet. Now, it says here the tree casts a 156-foot shadow. So the shadow of the tree is 156 feet. And we don't know the height of the tree. Now we want to know what is the length of the tree or the height of the tree. So this is what we would do. We would do the proportion. We would have 5 over x is equal to 12 over 156. Now we can do cross multiplication. 5 times 156 is equal to 12 times x. Now 5 times 156, we got 0, carry our 3, that's 8. So this would be 780 is equal to 12x. So now, the next thing we would do is to divide each side by 12. So what we would do next, we would take our calculator, we would take 780 divided by 12, and that gives us 65. So our answer here would be 65 feet is equal to x. That's the height of the tree, which is 65 feet. Now, we go to our next example. Our next example states that we need to find the missing length x. So we need to find the x value here. Now when we look at this triangle here, we notice that it is flipped upside down. Now we can redraw it and then get it to what we need it to be here. So if we redraw it, it will go basically like this. I took the liberty of drawing this here. Now if you notice here, directly across from the angle, we have the 8 inches and the 5 inches. So we know that they are proportional. So it would be 5 inches over 8 inches. And we would set that equal to, now we would have 7 inches and the x are proportional. So we would cross multiply. We would have 5x is equal to 7 times 8. So 5x is equal to 56. Now, we have to divide each side by 5. And x is equal to, this will give us 11.2. And that would be 11.2 inches. And that is what x would be equal to. Now, we scroll down here to the Pythagorean theorem. The Pythagorean theorem states this here. The sum of the squares of the length of the legs of a right triangle equals the square of the length of the hypotenuse. If the legs have lengths a and b and the hypotenuse have length c, then a squared plus b squared is equal to c squared. And that is the Pythagorean theorem. Now, it says example using the Pythagorean theorem. Find the length of the hypotenuse c in the right triangle. So what you would do is you would have a squared plus b squared is equal to c squared, because we want to find c. Now the sides are directly opposite their angles. So this is capital A. So directly opposite will be side A. This is capital B or angle B, and directly across would be side B. And we have angle C and side C. So now we substitute. A is 9, B is 12, and C we don't know. So this would be 81 plus